Hello. So this is a quick discussion on homework 6, question 1. So I'll give some tips on using LTspice to create a inverting op amp or to create an integrator op amp like the one provided here. So following the spice script, initially we see that we have to input a VS, a voltage source. So this voltage source is what kind of simulation are we doing? We are doing a DC simulation with an input that's sine wave. So the first variable is our offset, followed by our amplitude, then our frequency, our omega. 1 and 0 are the placement or the position of my voltage source. We don't need to care about them. So I right click, press advanced, choose a sine wave. Our offset is of 0.1. Let's before doing an sine wave simulation, let's just test things out with the DC simulation. Assuming that we have a DC value of 1, let's name our nodes. Let's name this node as VS and name this node as V out. We mentioned that we're gonna use a universal op amp. Any of those are fine. There are some differences. We can discuss them later, but for a universal op amp, there are some advantages. That it's basically an ideal op amp, and as we know that op amp is basically a gain at the output and a very high impedance. You can change these values here if you want. One good thing about op amps is that like you have different models. We just go with model 1. So it's basically a very high impedance at the input, which is 1 mega, and a gain at the output, which is 10 mega. You can, I think the op amp provided in the lecture note is 100 mega, but I don't think this will make any difference. You can change this value to 100, but it doesn't make any difference for us. Just like a large value. So let's run the circuit. So what kind of simulation? Let's do a transient analysis from 10. Just have it 10 milliseconds. Press OK. So if you plot the input versus the output, you will notice something that it's not what we expected. It's not an integrating op amp. It's just the input value of 1 and the output value is -1 times the gain. So the op amp is not functioning as we expect. So this we can discuss this in more details, but if you want to deal with it, you can just in your simulation or yeah, maybe in your transient analysis, just skip skip the initial operating point solution, which averages things in the AC. Hopefully this will fix our issue. Then we run it again. Yeah, so this is the result we expect. For our op amp with a DC input of 1, we expect the output to be the integration of this value, which is T. So like basically this makes much more sense for us. Let's change our input to a DC input, like the one provided to an AC input or a sine wave input with an offset of 0.1, an amplitude of 2, and a frequency of 1K. What happens when we run? Is this what we expect in the homework? If so, then that should be it. If you're not using an ideal op amp, you will have to feed your op amp with a